Jai Ho students, welcome to SK CBSE's Digital class session. Dear students, in previous class we have discussed about the finding of HCF by using Euclid's division lemma. How to find the highest common factor of the given two positive integers by using Euclid's division lemma. And also we have discussed the two important points. That is, the first point is every positive even integer is of 2q form. Every positive even integer is of 2q form, and every positive odd integer is of 2q plus 1 form. These 2 points we have discussed in the previous class. By using very important these 2 points, we have to solve this problem. Do you know what is this problem? In this problem, what they have given? Just look at the question. Show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5. Where q is some integer. It means we have to take one positive integer. Any positive integer we have to take. When we divide that positive integer by 6, then we obtain 5 remainders. Which are those 5 remainders? So if a number is completely divisible by 6, then we obtain remainder 0 or 1 or 2 or 3 or 4 or 5. So these all are the remainders, that is possible remainders we obtain the given number when we divide by 6. Clear? Suppose a is one of the number we have taken, that is a positive integer. A we have taken as a positive integer. When a is divided by 6, and what all the possible remainders we get? It may be 0 or 1 or 2 or 3, 4 or 5. So these all possible remainders we obtain when a number is divided by 6. Okay. So this point we have to keep in mind. How many remainders we obtain? We may get 0 or we may get 1 or we may get 2 or we may get 3 or we may get 4 or we may get 5. Clear? So these are the possible remainders when a positive integer is when it is divided by 6. Possible remainders are these. Okay. So first we have to take what we have to take, that let a is a positive integer. A is what? Positive integer. Positive integer. Clear? A is a positive integer. When it is divided. When it is divided by which number? 6. When it is, which one is divided? A is divided by 6. The possible outcomes, then the possible remainders. Then the possible remainders. Possible remainders are is equals to either 0, we may get 0, or we may get 1, we may get 2, 3, 4 or 5. Yeah. these all possible remainders we get when A is divided by 6. Okay. Suppose, now look at here, when R is equals to 0, suppose R is 0, then what happens? A can be written as 6Q. Why 6Q? Because remainder is 0 plus 0. That is, A is completely divisible by 6. That's why remainder is 0. So A can be written as 6Q when remainder is 0. When remainder is 0. A equal to 6Q. And 6Q can be written as 2 into 3Q. What we can write? 2 into 3Q. Means 3Q is a multiple of 2. Then we can say it is what type of number? Even number. This is even positive integer. Next come to when R is equals to 1. Remainder, suppose remainder is 1. What will be the A? A is equals to 6Q plus 1. A is equals to 6Q plus 1. This how it is to be written? That is 2 into 3Q plus 1. 2 into 3Q plus 1. It means 2Q plus 1. It is odd number. If it is a multiple of 2, then it is even. Multiple of 2 plus 1, it makes it is odd integer. Odd positive integer. Then we can say it is odd integer. It shows that 6Q plus 1 is positive odd integer. Next time, when R is equals to 2, when remainder is 2, when the remainder is 2, A can be written as 6Q plus 2. 6Q plus 2. So in both the terms, what is common? That is, common factor is 2. Common factor is 2. Or you can take 3Q, that is in this, what is common factor? 2 is a common factor. So that is 2 bracket 3Q plus 1. 3Q plus 1. So 2 3s are 6Q plus 2 1s are 2. Now you say this is only the multiple of 2. 3Q plus 1 into 2. Any number you multiply with 2, then that will be the even number. Then this will be the even positive integer. When the remainder is 2, then 6Q plus 2 is even positive integer. Next one, when R is equals to 3. Now you see here. When R is equals to 3, then A can be written as 6Q plus 3. 6Q plus 3. Remainder is 3. Again, this can be rearranged. That is, you can take 2 as a common factor. Or you can take first what we should do? 6Q plus 2 plus 1. We can write like this. That is 6Q plus 2 plus 1 is 3. So in first two terms, what is common factor? That is 2 is a common factor. If 2 is common factor, 3Q plus 1 plus 1. This is 2Q. That is 2 into 3Q plus 1 plus 1. It means here multiple of 2 plus 1. Then we can say it is odd positive integer. So this is odd positive integer when r is equals to 3. Next one, when r is equals to 4. When r is equals to 4, a can be written as 6q. A can be written as 6q plus 4. 6q plus 4. Again here 2 is common factor. So 2 you take outside, then 3q plus 2. It is a multiple of 2. So this is even positive integer. This is what we can say, even positive integer. Next, last, when r is equals to 5, then what we get? A can be written as 6q plus 5. 6q plus 5. Then this term, these two terms are rearranged. That is 6q plus 4 plus 1. 6q plus 4 plus 1. Then in these two terms, what is common factor? 2 is a common factor. So 2 you take outside, that is 3q plus 2 plus 1. Yeah. So it is a multiple of 2 plus 1. Then easily we can say that it is odd positive integer. Here, which all are positive odd integers? That is 6q plus 1 is a positive odd integer. 6q plus 3 positive odd integer, and 6q plus 5 is also positive odd integer. And we have shown that every positive odd integer is of the form 6q plus 1, 6q plus 3, 6q plus 5 are odd positive integers. Therefore 6q plus 1, 6q plus 3 and 6q plus 5 are positive odd integers. Positive odd integers. It is proved. Hence proved. I hope students you all understood this one. Now let us study one more example based on pattern. That is, the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. Okay. So in earlier example we have discussed that what we have taken, let a be a positive integer. Let a we have taken positive integer. When it is divided by 3, the possible remainders are zero, 1, 2, 0, 1 and 2. These are the possible remainders. When r is equals to 0, that is remainder is 0. When r is 0, a can be written as a is equals to 3q. When r is equals to 1, r is 1, then a can be written as 3q plus 1. When r is equals to 2, then a can be written as 3q plus 2. This is the basic information what we need to prove this one. Again, they have given what? The square of any positive integer. We have taken a as a positive integer. We have to do square. That is a square, a square, a square. Then after doing square, so what we have to get? Square of that number should be of 3m or 3m plus 1 form. Now, what is a square? Now, a square. Now, a square, that is 3q whole square. 3q whole square. So, what we get here? That is 9q square. 9q square. Again, this can be written as 3 into 3q square. Correct? So, this can be written as 3m, where m is equals to 3q square. When m is equals to 3q square. Next, a square is equals to 3q plus 1 whole square. 3q plus 1 whole square is equals to a plus b whole square identity. That is 9q square. 3 3s are 9q square plus 2 3s are 6q plus 1. 6q plus 1. So this can be written as, in the first two terms, what is common factor? 3 is a common factor. 3 you take outside. What we obtain? That is 3q square plus 2q plus 1. 3q square, that is 3 3s are 9q square. 9q square plus 3 2s are 6q. 6q plus 1. This plus 1. So here this can be written as 3m plus 1. 3m plus 1. Where m is equals to 3q square plus 2q. Where m equal to 3q square plus 2q. And last we have to take a square is equals to 3q plus 2 whole square. 3q plus 2 whole square. That is third term. When remainder is 2. Then this will become 9q square plus 12q plus 4 is equals to, again, what is the common in these two? Again 3q is common. That is 9q square. Once again as it is 9q square plus 12q plus 4 can be written as 3 plus 1. Now in these three terms, what is common? 3 is common. So write 3 as common. That is 3q square plus 4q plus 1 plus 1. Yeah, this plus 1 it is. So 3 into 3q square, 9q square plus 3 4s are 12q plus 3 1s are 3 plus 1. This one I have written here. So this can be written as 3m plus 1, where m is equals to, what is the m? This, that is 3q square plus 4q plus 1. It shows that any positive integer is either of form 3m plus 1 or 3m plus 1 form. So by this we will come to know that hence the square of any positive integer is either of the form 3m or 3m plus 1. I hope you all understood this concept. Okay. So in the next class we will study the fundamental theorem of arithmetic. Okay. So till then, take care. Jai Hind.